Who wants to find the domain and range? I do. Let's do it. Okay, domain and range for each of these, I'm going to use interval notation. I am not going to use the less than x, less than, I'm not going to do that. I'm going to do the braces or the parentheses. So first one is f of x equals just x. If you want to just draw this, you could. Let's put this thing in focus to where it doesn't go out of focus. There we go. Feel free to just draw it. I have actually already typed these onto Desmos so we can see them. Some of them are going to get a little bit complicated and we're going to have to kind of look through them. But the first one or two is not too hard, so let's do it. So here goes. The line x looks like, well, this. And because it looks like that, what we're really going to be doing is just looking, well, from left to right. So as I go from left to right, then basically my domain would be negative infinity all the way to positive infinity. So I'll write my final answer in red. Here we go. So domain is from negative infinity to positive infinity. And my range is going to be the y value. So from negative infinity to positive infinity. So it goes down forever and up forever here. And it goes left forever and right forever. So negative infinity, positive infinity. Okay, first one's done. We know what that graph looks like. This is these parent functions that we've been talking about. The next one is absolute value. You know what that looks like. Let's draw that one very quickly. And it looks like this. So as we deal with the domain, we need to be thinking, okay, how far to the left do I go? Well, I go forever to the left. How far to the right do I go? I go forever to the right. This thing goes forever this way and forever this way. Another way of thinking of it is, what x values can I plug in? I could plug in any x value that I wanted, any x value, and it would work. Now, in a minute, you're going to encounter one here where there are certain x values you can't plug in if you're going to keep them in real numbers and not in the complex, imaginary sort of realm. All right, I got a little blurry, so I had to unfocus it so it'll get focused again, and there we go, locked in place. So the domain on this one is negative infinity to positive infinity, and then the range is a little bit different. So as we look at the range, we think, okay, what y values will I get? In other words, what outputs will I get? What outputs do I get with absolute value, just pure absolute value, not translated, not dilated, not flipped up or down or anything? What outputs do I get? Well, I get positive numbers only, and 0, okay? So as I'm going up, traveling, looking for the y values, so 0 to infinity, and it does include 0. So this one's going to be, well, a bracket, or a brace, and then infinity, okay? The next one is a square root function, and the square root function is shifted to the left 2. Let's do it. So I'm going to draw it, and to the left 2. So this square root function starts here, and I'm going to go ahead and put a solid dot. I'm putting a solid dot there because I know, and you know this too, that what I could do is just plug in a negative 2, and negative 2 plus 2 would give me 0, and I do have a definite square root of 0. It's 0, so this point does exist there. So in a minute when we talk about the domain, we will put a brace there, not a parenthesis. So it does this, and then it goes up, it goes like that. So let's do the domain, let's do the range. The domain on this one is going to be, well, which x values can I use? You can look at the equation to figure it out as well. So again, looking at this, thinking, okay, what x values could I plug in? Well, anything from negative 2 and up, which we see on the graph, negative 2 to infinity. So negative 2 to infinity. We do not include infinity, we do include negative 2. And then the range, I'm thinking, what y values can I get? What outputs can I get? Well, just from a regular square root function, what y values do I get? None negative, but then I can get an output of 0, and I can get an output that goes all the way to infinity. Now, it's going to grow faster in this direction than it goes up, but it does go up forever. You can have square root that ends up being 1,000. That would be a million. Square root of a million is 1,000. So it'll go up forever. It just takes it a long time to get there. So the range is from 0, including 0, to infinity. Okay, and we can continue this idea and we can translate things around, and we've dealt with this before. In a minute, we're going to start using Desmos to graph some of these, and they're going to get a little bit tricky as we go. But I think we could do probably the next 3 by hand kind of quickly. And so let's do these as well. This is a parabola. that is shifted up 1. So I'm just going to go ahead and go for the obvious. The domain, in this case, we'll go ahead and put the R for the range. The domain in this case would be negative infinity to positive infinity. You can plug in any value you want. Negative infinity, positive infinity, it's going to work. The range is going to be any y value you can get as an output. So nothing negative, actually nothing between 0 and 1. But I can get an output of 1. If I plugged in a 0, I'd get a 1. And I could plug in anything greater than, I can get anything out of this function from 1 and up is what I was trying to say. You can see that from the graph. So from 1 to infinity. So 1 to infinity. Okay, next one is, well, parent function again. It's parabola, it's quadratic. But this one opens downward. And while we're at it, whoa, wrong color. While we're at it, I'll go ahead and draw this one too a little bit. At least do that much. There. Okay, so domain right here, negative infinity to positive infinity. No surprises there. Domain, negative infinity to positive infinity, which means I could plug in any x value I want, any real value I want, and I will be able to get an answer that shows up on this graph. The range, what outputs can I get? Well, my range is going to be, I like to start at the bottom. So can I get an output here? Well, yeah. Could I get an output here? Well, yeah. I can get an output as far down as I go. So negative infinity, I always go slowest, lowest to highest. So negative infinity all the way up to and including 0, but nothing above 0. So the range is negative infinity to 0. Brace on the 0. Okay, here goes. Horizontal shift of positive 2, vertical shift of negative 3. Let's go ahead and do that. So positive 2, negative 3, and this is a square root function, which looks like, well, that, and it goes up, and if you're like, hey, where do I cross the x-axis? Let's not worry about the specifics of that. I'm looking at the general shape, and what I'm really looking at is, what's the domain? What's the range? It makes that sound. So the domain is, nope, 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 nope. Yes, that would be from 2, including 2, all the way to infinity. So domain is from 2 to infinity. And the range is, nope, 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 hadn't hit the graph yet. Now I've hit the graph at 3, and it goes up forever. It goes off this way, but it's still going to go up forever. It just takes it a while to get there. So from 3 to infinity. Oops, that should be negative 3. There we go. And now we get into some other ones that we could totally do by hand, but they're going to get a little bit tricky, so we're going to start Desmosing these. And so the next few, I'm going to go ahead and start writing like domain and range, 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 domain and range. What's this? Sine of x? Heck yeah, it's going to be interesting. Okay, let's go to Desmos. And that's not it. That's a spreadsheet of all the lessons. And I'm going to do, let's see. Let's start with this one. That's what this one is. That's the next one we're doing. So domain. What's the domain? Well, does it go over forever? I can't tell. This is why I have this on the TV. Because I can do cool things like this. Yes, it goes to the left forever. And it goes to the right forever. You can't do that if it's not a touch screen. But in this case, I can. So there we go. Negative infinity to positive infinity is my domain. So what's my range? I'm going to go back to the regular screen. So negative infinity for my range. I'm way down here below the TV. And I'm coming up, coming up, coming up, coming up. Boom. And it stops at a y value of 0. So let's type those things in. Or write those things down, I should say. Using the correct color pen, which I left over there. So the domain was, that's not it. You're looking at the wrong thing. Negative infinity to positive infinity for this one. And the range was negative infinity to 0. Okay, next problem is not there. We'll get this right here in a minute. The next problem is that. And this one is exponential, you can kind of tell. And I wonder how far to the left it goes and how far to the right it goes. Well, let's go ahead and go for the obvious. How far to the right does it go? Forever. This thing is going to go forever to the right. I could drag this thing for the rest of my life. That would be a waste of time. And I would never, ever, ever, ever run out of a green graph over here. And if you're not seeing it, here, let's make it a little bolder. There we go. Never. Now, I do want to point out something, and this is going to come in handy in just a minute. If I stretch this way, and I don't know if I'll be able to do it well enough, but if I stretch it just right, you'll probably notice that I'm around 90 actually, at the X value of 90. If I stretch it just right, I'll run out of it, dang it. There we go. Oh, it didn't show up. It's not going to show up too well. Here's the deal. It is never, ever, ever going to touch the x-axis. It's going to get super close. It's going to be so close that the computer doesn't even know what to do with the resolution. But it's never going to touch the x-axis. That's what I was trying to do as I was clawing at this thing. So it's going to get closer and closer to the x-axis, but never touch it. That's going to be important when we get to the range. But I'm getting ahead of myself. Let's finish the domain. Okay, domain, forever to the right, but to the left, what does it do? Let's see. It looks like it kind of runs out. No, it doesn't. This graph, I could plug in any x value I want from negative infinity to positive infinity, and it would give me an output. So any x value will work right here. So I'm going to go ahead and write that without going to the wrong screen. I'm going to write that for my domain. And now for my range, make it sound like a magic trick. And now for my range. My range, let's go back to the regular viewed screen, regular standard zoom. I would say, okay, nothing in the negatives, and then 0. Well, I just told you a minute ago, this thing will never touch the x-axis. So 0 is not an option, right? So not 0. So from 0 to infinity, but not including 0. So if you're thinking, well, not including 0, shouldn't there be an open circle? No, not necessarily, because it's not going to come down and like bounce up. Excuse me. It's not going to come down and bounce off. Be careful how you say that. You might burp. But what it is going to do is just get really, 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 really close, but never, ever touch. And for that reason, this is parentheses 0 to infinity. Okay, this next one right here, negative square root of negative x. It's going to get a little bit tricky. And there it is right there. I'm going to make it a little bolder. And as I do that, again, looking from left to right to see what my x values could be, what my y values could be, from negative infinity to 0. So my domain is negative infinity to positive, well, to 0, just plain old 0. So let's go ahead and write that down. Negative infinity to 0, including 0, because you could plug a 0 right there. And I know you'll be like, oh, but you can't take the square root of a negative number. It's 0, so it's okay. You're fine. There we go. And let's deal with the range. All right, range. How far down does it go? Well, if you want to get technical, you could do this, and it's going to go down forever. It's a little more easy to visualize that way, a little easier to visualize. But it's negative infinity up to 0. Okay? Negative infinity to 0. All right, the next one is a cube root. And here's the standard viewing window for a cube root. Let's go for the obvious. Negative infinity to positive infinity for the domain. I think that's obvious. And then we could, let's do this. We can go negative infinity to positive infinity for the range. This thing is going to go down forever and up forever, but not nearly as much as it spreads out this way. But it eventually, I mean, given all of eternity, it'll eventually go up to infinity. That could even happen. But negative infinity to positive infinity for both domain and range. And that's good to know for some of these parent functions. This is a parent function. And it's a parent, haha, but its domain and range is. Domain and range are. Bad grammar, sorry. Okay, 2 to the x minus 4. This one is quite tricky, and I'm not a big fan of this problem. Oh my goodness, what's happening? Trying to scroll, it's not working for me. Here it goes. 2 to the x minus 4. Actually, let's go ahead and do 2 to the x. I'm just going to pretend like it said 2 to the x, and we're going to stare at that first. So this is 2 to the x. All right? 2 to the x. What's the domain? Negative infinity to about here? No, actually. Negative infinity to positive infinity. I could keep smushing this thing and it would just keep going over to the right. Negative infinity to positive infinity. Now I know I took out that -4. That -4 is going to shift this whole thing down. So hold that thought. Let's do domain first. That vertical shift is not going to affect the domain. Negative infinity to positive infinity. The range, on the other hand, based on what I have right now. Right now, changed it, took out that -4. Okay? No negatives for my range, but it would be from 0 to infinity. And no matter what you plug in, you will never ever touch the x-axis. The screen resolution will probably not represent that, but it will never touch the x-axis. Not going to happen. So the answer, having modified it, is from 0 to infinity, but not including 0, parenthesis here. So 0 to infinity, but that wasn't the problem. This was the problem. So instead of from 0 to infinity, this whole thing got shifted down 4. So the range is from -4, again, not including -4, to infinity. -4 to infinity. All right, last one. I love the graph of sine. You're going to encounter this later in the class. This is a, well, sinusoidal graph because it's sine. If it was cosine, would it be called cosinusoidal? I don't know. I've never heard that word. There it is. Interesting, huh? How far to the left does it go? Negative infinity. How far to the right does it go? Positive infinity. So we know the domain. Now, you might be looking at that saying, why does it make this wave and what is it doing? Well, it's just cycling back through over and over, which is why it's a wave. We're going to discuss this later in the class. It's one of those things, it's like a foreshadowing of things to come. Domain, negative infinity to infinity. Range, how low does it go? Sounds like it's limboing. How low can you go? Nope, 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 nope. Yes, and where is this? That'd be -1. So I can get outputs of -1, and it happens over and over and over and over again. And my highest output is +1 over and over and over again. So my domain is negative infinity to infinity. My range is -1 to 1, and it does include both of those.